The next version of Zig 0.16 something is going to hit like a tsunami. A lot of work is being done and it will transform how we write Zig programs. There will be a before and an after, and to prepare for the post-IO apocalyptic world, I've decided to make a few videos about the incoming changes, and today I want to talk about the new juicy main. It started as a proposal to allow us to receive a bunch of goodies in main, like allocators, a default IO implementation, environment variables, CLI arguments, and more. This issue also discussed the introduction of a minimal opinionated CLI argument parser, but this discussion has been moved to another issue and is still ongoing, so I'm not going to talk about it. So let's focus on the juice. There are now 3 ways to define the main function. With no parameters, as usual, with 1 parameter of type std.process.Init, and with 1 parameter of type std.process.Init.Minimal. And as you guessed it, these new parameters are what is going to give us the goodies. But what's important to understand is that it's not just a new convenient way to receive some useful stuff. It's also now the only way to access environment variables and CLI arguments. Because as you can see, the title of the issue that merged the juicy main starts with std delete os.environ os.argv. So the old way of interacting with environment variables and CLI arguments doesn't work anymore. So you can still define a main function with no parameters, but you will not be able to access CLI arguments or environment variables. The reason why std.os.environ and std.os.argv have been deleted is because they are food guns. You see, on Windows, you have the PEB, the process environment block, which is a data structure created by the kernel, which contains the different process parameters that a process can use at any time. However, platforms like Linux don't have such kernel structure, and the CLI arguments and environment variables are only available as arguments passed to the entry point. So the common abstraction is to make them global, but environ and argv were initialized to undefined and then populated in the start code before main. So if you were making a library and not linking libc, then there wouldn't be any guarantee that they would actually be populated. So a user could potentially try to access an undefined value, which is a problem. But now that they have been deleted, it's safer. But if you want to use CLI arguments or environment variables, you must use std.process.Init or std.process.Init.Minimal. std.process.Init.Minimal has 2 fields, one to manipulate the environment and another one for the command line arguments. So if you only need that, you can create a main function with a parameter of type process.Init.Minimal. Here the name of the parameter doesn't actually matter, but I guess init is going to be pretty popular. So let's use that. Then you can get the CLI argument by using the iterate method of init.args to get an iterator, and then call next on it to go through the list of arguments. But this doesn't work for Windows or WASI, so instead you can use iterate allocator with the allocator of your choice. If you prefer, you can also use args.slice, but an arena-style allocator must be used. Okay, now for the environment, you can access it using the environment field. You can check if an environment variable exists using contains an empty, contains constant, or contains an empty constant. The difference between the constant and non-constant version is that the non-constant versions create an environment map, which is probably a bit of a waste. But environment map provides a few useful methods, so you can create one using init.environ.createMap, and then you can, for example, list the environment variables using the keys and values functions. Or if you want the value of a specific variable, you can simply use getAlloc or getWindows on Windows or getPOSIX. Okay, that's pretty much it for init.minimal. Now let's look at its chunkier brother. std.process.Init is a superset of minimal because it has a field named minimal of type Init.Minimal. So if we create a main function with a parameter of type std.process.Init, we can pretty much copy paste all the code we've seen so far, but instead of using init, we will use init.minimal. Init also comes with a populated environment map, so we don't need to create one, we can just use the existing one. It also comes with an arena allocator and a general purpose allocator ready to go. You can just plug them in your application and you don't even need to call dinit. Init also provides an IO implementation, and now that a lot of functions require an IO argument, this is going to be very handy. We now have access to 2 allocators and an IO implementation. But which one? To know what we actually get, we need to look at the start code. The GPA allocator will be the debug allocator in debug mode, the C allocator if you're linking libc, the wasm allocator if you're targeting WASI, or SMP allocator. The arena allocator will be the classic one, and IO will use the threaded implementation. Finally, init also has a pre-opens field for people who cares about WASI. But from what I understood, it corresponds to a list of directories that the WASI runtime gives to the process so that the sandboxed process can actually interact with the host file system or something like that. I will learn about WebAssembly one day. So yeah, that's pretty much it for the juicy main. We now have 3 ways to define the main function, and the way we interact with environment variables and CLI arguments has completely changed. So now go and get the juice and subscribe. Holy, you'll go get the juice. Man, no sus jokes in this video.